Greetings, science students. In this clip, we're going to take a visual approach at distinguishing between the properties of elements versus compounds versus mixtures. So elements, as we know, are the building blocks of all matter in our universe. And the key characteristic that we use to distinguish an element from a compound or a mixture is that they can't be broken down into subatomic particles with ordinary chemical processes. So there are 6 elements on the periodic table that are monatomic. The rest are made up of multiple atoms that are the same in terms of the arrangement of their protons, neutrons, and electrons. And so the 118 elements are arranged in the periodic table based on the number of protons that we have in the nucleus. There are 2 key criteria for compounds. Number 1 is they are made up of 2 or more different elements. And number 2, they are chemically bonded, which means it's very difficult to separate them. So if we look at this image here, these top 4 satisfy 1 out of those 2 criteria. They are chemically bonded, as signified by basically attaching those atoms together in the particle diagram. But they are not made up of different types of elements. So therefore, we don't classify them as compounds. We simply classify them as elements, diatomic elements. These bottom 4, these are compounds. These satisfy both criteria because they are chemically bonded, as we can see from the way that the particles have been represented, and they are made up of 2 or more different types of elements. Then we get into mixtures. So mixtures are made up of 2 or more different substances that are not chemically bonded. So we can separate these using appropriate separation techniques. An example of a mixture is air. So the air we breathe in is made up of an array of different gases that can be separated into compounds, into elements, etc. So let's test your understanding of elements versus compounds versus mixtures by looking at some particle diagrams. So with this one here, is it an element, is it a compound, or is it a mixture? Pause the video, contemplate that one. All right, let's get into the answer. This indeed is a mixture. Why? Because if we look at, say, these 2 molecules, they vary. So what we have here is we've got some individual elements here, and we've got a compound here, and these 2 are not bonded with one another. So this indeed is a mixture. Same deal, element, compound, or mixture. Again, if we have a close look at the particles in this image, we can see that there's no uniformity. We've got a bunch of these black elements, a bunch of these red elements. They're not chemically bonded. So again, another mixture. What about this one? Well, if we go back to our criteria for compounds, got to be made up of 2 or more different elements, so we can eliminate that. It's not a mixture because we don't have 2 or more substances that can be separated. We've just got a single type of atom. Yes, there are multiple atoms here, but this is an example of an element, a pure substance. Again, use the criteria for elements, compounds, mixtures to determine your answer here. So if we look at all of the individual molecules in this particle diagram, they've all got one of these big atoms and they're all chemically bonded to 2 grey ones. Again, every single molecule in this diagram is the same in terms of the arrangement of one big red bonded to 2 grey ones. So therefore, this is an example of a compound. There are 2 or more different elements that are chemically bonded. Whilst this one has some common ground in terms of some of the compounds, We also have some of these individual green elements and some of these yellow ones. So because there is no uniformity in each of the individual molecules, here's another mixture, 2 or more substances that are not chemically bonded in terms of these compounds are not bonded with these yellow or green elements. Hopefully we're now getting the hang of this now that we've done a few of these. So again, we've got 4 molecules here and we've got some consistency. They're all comprised of one of these large black atoms that is chemically bonded to these 4 red ones, and that is the same case for all 4 of those molecules. So again, this satisfies the criteria for a compound, 2 or more different elements that are chemically bonded. What about this one? Again, when unsure, go back to the criteria, element, compound, or mixture. Well, this one only has a single type of atom that is chemically bonded. So because it's only got the one type, that eliminates the possibility that it's a compound. And same deal with a mixture based on the bonding. So therefore, we have an element here, a diatomic element. Final one, element, compound, or mixture. Again, working with the criteria, we've got the chemical bonding here for all 3 molecules. So therefore, we can eliminate a mixture. And we've got 2 or more, 2 to be precise, different elements in each molecule. So we've got another compound here. I hope that was useful.